Alright, and welcome to Variation Level 1. Now, in our very first example, it says this: A varies with B in the table below. Label your independent and dependent variable and describe the relationships between A and B. So here's how I really want you to start these problems. I want you to go ahead and start by drawing a vertical t-chart. And notice that B is actually the first letter that we see, so we'll put B first, and then we'll put A. And let's go ahead and label these values. So we have 5, we have 11, and we have 17. Okay. And then over here for A, we have 6, we have 9, and we have 12. Now the cool thing about this video is we're not really going to do too much math. We're going to look at trends. So when you look at B from 5 to 11 to 17, what do you notice? Well, these values are increasing. And when you look at the 6, the 9, and the 12, what do you notice? Those values are also increasing. So they're getting larger and larger and larger. So what we say is as B increases, well, so does A. A increases as well. And so what happens when both B and A increase? Well, when the two things do the exact same thing, we're going to call this direct variation. Direct variation. And I do apologize having some stylus issues. So we have direct variation. Doesn't write as nicely and neatly as I would like. And in later videos, you're actually going to have to use this formula, which is going to be y is equal to, oh, come on now, kx. Now, the very last thing that I want to do here is I want to talk about how do you label these things. Well, when we have this very top line there, we know that these will always be our inputs, or what we call our independent variables. Independent, let's see if we can write it, independent. Okay, so B are going to be our independent variables, and right here, A, those are going to be our dependent variables. Dependent. Okay. Now, what's important about that? You just have to understand that whenever you have an independent variable, that is ultimately going to affect the dependent variable. So whereas B doesn't matter what we choose, A will always be directly dependent on B. Okay, let's go ahead and move on to our very next example. Okay, here we are in our second example, and this one says R varies with Q in the table below. Label your independent and dependent variable and describe the relationship between R and Q. Now, as an extension of our first example, I want to really dive into this statement right here, where it says blank, or R varies with Q, but I want to write this: blank varies with blank. By the way, if it seems like I'm writing really slow, it's just because I'm having a little bit of stylus issues. It takes a second for the pen to pick up. So blank varies with blank. And of course, in this one, we have R varies with Q. So this sentence is so important because it's always going to be the same no matter what. What we're really saying is that whatever letter comes first is the dependent variable, which I will just abbreviate with DEP, that's our dependent variable, and Q is going to be our independent variable, all right, which I'll just abbreviate with IND. So notice that this statement is always telling you what's your dependent and your independent variable. And what does this really mean? It means that Q is independent. We can pick any number for Q, it doesn't matter, but whatever number we pick for Q is going to ultimately dictate how R behaves. Okay, now let's put this in a very, very concrete structure. So we see that Q comes first because it's our independent variable, and Q is -6, and let's see, -3, and also -2. Okay, and notice that our R values are going to be -2, -8, and of course -14. So we have some questions here. Question number 1 is, how is Q behaving? Well, when you go from -6 to -3 to -2, you're getting less negative. You're approaching the positive numbers, so you are, in fact, increasing. And what about r? What's happening with r? Well, we're going from -2 to -8 to -14. We're actually going more negative. And so remember, when you're going more negative, you're actually decreasing. And the best way to think about that is in terms of money. As you go more negative, your bank account goes more negative, you are owing more and more money. It means that technically you have less money. Your amount of money is decreasing. So as Q increases, R decreases. When these two things do the opposite of each other, when they're not going in the same direction, we call this inverse variation. Okay, inverse variation. Now, I'm going to abbreviate variation with just VAR because I'm running out of space, but the important takeaway is that whenever you have inverse variation, our formula is no longer y equals kx, it's now y is equal to k divided by x. And so this is truly important because understanding if we have direct or inverse variation tells you which formula to use. Let me give you one more example of inverse variation. What if we had some inverse variation where Q was decreasing, but R was increasing? Well, notice in this case, they're still doing the opposite. So whenever they do the opposite of each other, that is inverse variation. All right, let's go ahead and move on to our... Okay, here we have example 3, and a rancher has enough barbed wire to create a fence with an area of 1,000 square yards for his 4 cattle to feed. Given the width varies with the length, what type of variation will the length and the width have? Okay, so let's pick a very, very simple example. Let's say that this farmer is wanting to create a rectangular fence. You know, he could get fancy, he could do all sorts of shapes, but let's just go with a rectangle in general because I think it's easier to see. And we're going to say that here we have a width and here we have a length, and he wants to have enough area to have 1,000 square yards for his 4 cattle to feed. Okay, now, given that the width varies with the length, wait a second, that is an incredibly important statement. I want you all to look at that. The width varies with the length. That actually allows us to understand which one of these is our dependent and independent variable. Remember that your dependent variable always comes first, so the dependent varies with the independent, and so that means that our length must be the independent. Now, when you have a conceptual problem like this, I think it's really important to just kind of pick some numbers to play around with. So we know that our independent variable is the length, and our dependent variable is the width. And let's just pick some numbers. Let's say we wanted like a really long fence. Well, we could make it 100 yards long, and then we could make it 10 yards wide. 100 times 10 would give us 1,000. But what if we shrunk this? What if we took the length and we made it only 50 yards long? Let's see. How long would the width then have to become? See, it wouldn't be... Would it be 20? Yeah, it would be 20. So this is kind of interesting. If we take the length and we cut it in half, what happens to the width? It actually doubles. Let's try this again. What if we took the length and we dropped it from 100 to 50 to 25? We halved it again. Well, then that would imply that the width could become 40. And you can test these numbers out yourself. Use a calculator. What is 50 times 20? What is 25 times 40? What's 100 times 10? All these things are going to come out to be 1,000, so that 1,000 can't change. But notice that as our length is decreasing, our width is actually increasing. And so ask yourself, what type of variation do you have when one decreases and one increases? And of course, we know that this is going to be inverse variation. Okay, inverse. Remember, I'll abbreviate variation with just VAR. Now, why is that so important for you to recognize? Well, that allows us to pick the correct formula, which in this case, inverse variation will always be y equals k over x. Okay? We're not going to really do anything with that formula for these equations, but just understand that inverse variation does have the formula y equals k over x. All right, let's go ahead and move on to our final example. Okay, here we are in our fourth example, and it says this. You decide to go for a walk, and the further you walk, the more the time increases. How does time vary? Let me put little quotation marks. How does time vary with the distance walked? Now go back to our second example. Think about that statement. When blank varies with blank, it's always the very first thing that is our dependent variable. We're saying that time is dependent on the distance walked, which becomes, of course, our independent variable. And think about this like really concretely. If you walk, the further you walk, the more time it's going to take. That should be pretty simple. So let's go ahead and draw our t-chart. Let's see if I can squeeze this in. Here is our distance. I'll even just abbreviate distance. And here is going to be our time. Okay. And so let's just think about this like really, really concretely. Like let's say you walk, let's choose blocks. Let's say you walk 5 blocks. And let's say 5 blocks takes you 10 minutes. And the units don't even matter here. But let's say you decide to walk 10 blocks. Well, if you walk twice the distance, you're going to walk twice the amount of time. Let's say you decide to walk really, really far. Let's say you walk 100 blocks. Really, really going to get it today. Well, you're going to walk twice as much time, so let's say that's going to be 200 minutes. And that'd be a very, very long time. That's going to be over 3 hours. Okay, so we see that as our distance increases, our time is also increasing. And so, of course, since they do the same exact thing, we know this will be an example of direct variation. Okay, once again, I'll abbreviate variation, just VAR. And of course, whenever we have direct variation, we know that y is equal to kx. Okay, one final thing. I think with the one thing I really haven't covered in these videos, like what if you had something where the distance was decreasing and the time was also decreasing? Well, you should be able to answer this question. Are they doing the same thing or are they doing opposite things? And since they're doing the same thing, we know it's still going to be direct variation. So if two things are both increasing or if two things are both decreasing, they're doing the same thing, it is direct variation. If one is increasing and the other is decreasing, or one is decreasing, the other one's increasing, we know it's inverse. So just really hold that thought in your head. If they do the same thing, direct variation. If they do opposite things, inverse. Alright, well I hope these help and good luck.